This is example 3 in your book on page 62. And again, the reason I'm doing the examples is because I think they're great examples, but also the book, of course, tends to skip some intermediate steps. If you want to read the example in the book and you don't need the intermediate steps, then that's okay. Feel free to just read the book, but I notice usually students get stuck on an intermediate step that they're not catching. Okay, so we have this initial value problem, right? IVP, because we have our initial condition. And here they're telling us specifically that x naught, right, is positive. Okay, so we have a positive x naught. And here on your exam, I will say solve the differential equation by, in this case, we're going to use by substitution, because if you try to separate the variables, you can't, well, you actually can't, but it gets ugly, especially with this square root of difference of two squares. I encourage you to try, and you'll see why you want to use substitution. So again, by substitution, so we want it as a function of y over x, right? That was the key, right? So on page, again, a homogeneous first order differential equation, right? This is from page 60, right? We want to write this as a function of what? Of y over x. So why did I choose y over x? Well, because I noticed that if I divide both sides by x, right, I'm going to get a y over x here. So that's why I want to choose y over x. So obviously this is a 1. dy dx equals y over x, all right, so we're happy about that part, plus the square root of x squared minus y squared all over, all over x. Okay, so we have a nice, right, y over x, right? We want a function of y over x. Now this is the expression that we want to rewrite so that we can easily see a y over x in here. So in order to do that, and actually that this is why this is important, this part here, the fact that x naught is positive, we can rewrite our expression. So the left hand side is just the same, y over x. Okay, so I can rewrite, so the numerator stays the same for now, all over, okay, x, I can rewrite that as the square root of x squared, right? That's the same thing as x, right? Assuming x is positive. So that's what I'm using, right? This is just a property in algebra that you should hopefully be familiar with. So now that we have two radical expressions here, we can use radical properties from algebra. So again, a lot of this is really just recalling a lot of algebraic properties. So I'm going to use the square root of a over the square root of b is the same thing as the square root of a over b. So I'm going to write the square root of my numerator over the denominator. And I'm going to just go ahead and split it up right now because we're going to do that in the next step anyway. If you want to write one bar and then in the next step split it up, that's okay. So we have, again, just continuing, dy dx equals y over x plus, and then of course we have 1 minus, and then we have y squared over x squared. But we know that that's just y over x squared, which is great because now we have our y over x. So now dy dx is a function of y over x. And again, I want to emphasize, right, this is the capital F of y over x that the book keeps talking about on page 60, right? This is a homogeneous first order differential equation. So now we can make these substitutions. So let's start our substitutions. So we're going to let, let v be y over x. Okay, so we're definitely going to use that. And if we cross multiply, solve for y, we get y equals vx. And finally, to obtain our third equation, right, we can differentiate with respect to x, right, using the product rule here. So it's going to be dy dx, right, or ddx, right, if you want to say ddx of y equals, well, let me just go ahead and write it. It doesn't hurt to write the whole thing. It's good practice. ddx of vx. And okay, so dy dx equals, and then if we use again the product rule, we simply have v plus x dv dx. Again, I just used the product rule, right? Derivative of x is 1 times v, and then of course x times, this is my v prime. So again, product rule. Okay, now we're ready to substitute our equations, right, in terms of v. So let me just go ahead and box this because we're going to use these three relationships. Okay, so what was our original problem? Okay, so I'm going to substitute it into this guy, right? I mean, our original differential equation was this guy way up here, but I mean, this is still in terms of, we want to use the one that has the visible, the clear y over x expression. Okay, so let's move this. I'm going to use that one, and okay, so I'm just going to, again, substitute. So dy dx is, well, it's this guy right here, so I have v plus x dv dx, right? That's my dy dx. Might as well use some colors here, it doesn't hurt. So dy dx, there's my dy dx, equals y over x. Well, y over x is just v, so that's v, and I think I made it this pink reddish, and plus the square root of 1 minus v squared, because we have y over x squared. Okay, so there is our, right, this guy is a function of, right, g of x and v, right? We started off with a function of x and y, right, and we transformed it into a function of x and v. Okay, so now we ask ourselves, can we separate the variables with this information now, this function of x and v? So let's see if we can get our v's with v's, x's with x's, and let's see, I'm going to multiply both sides by, let's see, d, oh, this is nice, because my v's are gone, so even better. I can multiply both sides by dx, so that's going to give me x dv equals this guy. And let's see, I can divide both sides by the square root of 1 minus v squared dv, and then I can divide both sides by x. So notice we separated the variables, or in other words, this equation is separable, right, when it's written in terms of v and x, but it's not separable when it's written in terms of x and y. So again, we want to use the information or the techniques that we've already used in 1.4 and 1.5. So this guy is ready to integrate. So let me just get a different, I'll get purple here. So integral, and this is a nice integral, right? We've integrated this already. If you look again in the inside cover of your book, 1 over the square root of, right, a squared minus u squared dv. This is just sine inverse, right, of, in this case, it's v over 1, or just v. And we have, well, this guy is just a natural log of x, right? And I don't write the absolute value because it's telling us that our inputs are positive. And then, of course, our constant of integration. So remember, our goal is to solve this differential equation, right? Y of x. We rewrote this equation, right, in terms of v. So we have to go back to y over x and eventually y. And just below the problem in your book, they do a nice explanation of how they get there. It's only a couple of steps. So I encourage you to read that. Again, this is on page 62, just because I have a certain limit on this this app. It doesn't let me exceed a certain amount of minutes. But if you have any questions or you're not sure how you obtain your y of x, then please let me know and I will write all the steps for you.